Let's talk about the full life cycle of nuclear power. Now, this has a lot of controversy associated with it, so we're going to break this down piece by piece. Let's first talk about the building itself. Now, there's nothing really that special with the building of a nuclear power plant. It's made out of concrete and steel and other forms of metal for the most part. For the reactor itself, there's a small amount of potentially hazardous materials, such as boron and the uranium fuel rods themselves, and other things that are related to that. But that is a very, very small portion of the overall structure. So it's worth noting, but that's about it. And we'll talk about how the fuel rods are processed and disposed of later on, which has its own process. Now, the fuel is interesting. Uranium is found all around us. It is an element, so we have to go find it in a spot where there's a high enough concentration to make it worth mining. When you're mining it, you can actually just take most of the dirt that is not anything with uranium, put it right back where you found it, and it doesn't cause any serious damage. The most serious thing that can happen is if you have a lot of radioactive dust that can be kicked up through this process that people could breathe in and potentially have some issues. There have been a few documented cases of this being a problem, but it's not really that dangerous compared to any other type of mine. Now, you do have radon, which is a very serious concern anytime you're digging down into the earth. But it turns out that any form of metal that you're digging, you're going to have radon as a problem. So it's something to always be aware of, but it's not a huge concern necessarily, more than any other form of fuel out there. This also includes the digging of metals for the various types of solar, wind, whatever kind of power you use, you're going to have some of these issues. The processing of the fuel rods does involve some fairly harsh chemicals, and these chemicals can be recycled, and while it's something that you need to be aware of, the size of a typical fuel rod that will power you is not really that big. I forget exactly what it is, but something like a golf ball sized of uranium will provide all of your energy needs for your entire life. And when it's disposed of, it'll be about the same size. So, yes, when you combine a lot of people together, you have a much, much larger sum of this than you would otherwise. It's still not a huge amount of anything, and so therefore you're able to get away with some economy of scale. We have the manufacturing of the fuel rods. What about when they're actually being used? Radioactivity is something to be concerned of. People do die because of radioactivity. If you release it in certain conditions, it can cause increased cases of cancer. The regulations that radiation workers undergo to protect themselves against radiation are very, very strict, and if they're properly followed, they'll never have an issue with this. It's something to be aware of, but it's not something that a typical person will have problems with, even working in there. In fact, many of the people who work in a nuclear power plant are some of the biggest proponents of the power, even though they are the ones who are exposed to more radiation than your general public. Under the normal operations of a nuclear power plant, it will not actually discharge any radiation. In fact, it tends to absorb a little bit of radiation from the surviving environment. Now, there is a lot of low-level radioactive waste in the form of clothing, protective gear, and such that can be disposed of, but it's not any more radioactive than really anything. When you are decommissioning a nuclear power plant, and this isn't something that's been done a lot, but it has been done, other than the nuclear reactor itself, which is only a very, very small portion of the entire facility, the rest of it can be disposed of just like you would anything. It just has the electronics and the metals and so on and so forth. The reactor will need to have some special processing. It has some radioactive material. You may need to toss it into a more secure type of landfill, but it's not really going to pose any serious danger You just have to deal with it the same way you would deal with any kind of hazardous chemicals. The one thing and only thing during the nominal operation of a nuclear power plant is the fuel rods that can cause any significant danger. Now, you don't want to be anywhere near a spent nuclear fuel rod that is just out in the open. Those things have some very, very nasty stuff, especially if it came right out of the reactor. You want to make sure you're using special machines to deal with it, and you don't want to be close to it. So what happens to these fuel rods when they're done with? Well, the first thing that they'll do is they put them into basically a pool for about 10 years, and that will take all of the short-lived isotopes that are in it and allow them to burn themselves off, so that way it's no longer this really, really hot substance. It's much, much cooler, and that allows it to be stored safer for a longer period of time. At this point in time, we can actually take a dry cask, basically something akin to a block of concrete, stick the fuel rod in there, and it will be safe. You could go out and touch these dry casks and you'll be safe. You won't have any large amount of radiation exposure whatsoever. They have some special windows so you can actually verify that the fuel rod is still there, because there's a damage of nuclear proliferation where you can use some of these to generate material for nuclear weapons and things like that. We'll talk about that in a moment. There's basically 4 families of isotopes that tend to live in these. You have the short-lived ones that will be mostly gone within about 10 years. These isotopes are some of the nastiest ones. Once they're gone, then the amount of radioactivity drops considerably that's coming from these. Then there's a second family of these that takes about 100 years for it to start to burn out. And once 100 years has passed, then the rods are again significantly less radioactive. There's a kind of tailing that happens over a long period of time, though, and it has this kind of step-shaped type of function to it. But the really long-lived isotopes can be pretty nasty and are around for a long time. These tend to be the stuff that is larger than plutonium on the periodic table, neptunium, americanium, things like this. There's some nasty stuff, and of the entire fuel rod, only a very small percentage of it is this really nasty chemicals that you have to make sure that you're containing. Most of a spent fuel rod is uranium-238, which is found in nature literally everywhere. It's the single largest component of natural uranium that's found all over the place. That's our gold standard, not really caring that much about that. If we achieve that level of radiation, we're doing fantastic. So in theory, we could sort out just these really, really nasty chemicals and let the rest of it be tossed into basically a landfill, and it wouldn't really cause any issues. Now, sorting these out is actually quite difficult, and it's not something that anyone's really attempted to do. Another thing of some interest, though, is we could actually throw these rods into a breeder reactor, which is actually the very first commercial nuclear power plant was a breeder reactor, but it's not the kind that we typically use today because, well, it has to do with the Cold War. The design of reactors that was the most easily available was the type that was used in submarines, and submarines you optimize for things differently than you would otherwise because it's the military. Still, it remains very likely that someday we will take these nuclear fuel rods that are spent, run them through a breeder reactor, and by so doing we can generate even more electricity from them. And when the breeder reactor is done with them, then it's created more energy, so the nasty stuff, it's been changed into energy, which is fantastic. Let's talk about the nuclear proliferation. Now, this can happen, and then some reactors are specialized for this. However, the way that you get this is by taking a fuel rod that has been only partially used and not fully used to the point where you're not getting much energy from it. And that will tend to have a higher amount of these isotopes that are necessary to make nuclear weapons. A spent fuel rod doesn't really have these certain types of values. That's the stuff that you're getting electricity from. It's only the countries that are really trying to project power, like the United States, Russia, and a few other ones, who bother to build nuclear weapons. For the most part, this is not something that a lot of people want. One side fact, the nuclear weapons that came from the Soviet Union when they started to downsize, a lot of the fuel from the nuclear reactors that we've been using in the United States came from these weapons. So one of the best ways to get rid of nuclear bombs is to use commercial nuclear energy, because it will get rid of this material and turn it into useful electricity. Finally, let's talk about the issue of nuclear disasters. Now, nuclear disasters happen, and they're a bad thing when they do. There's been 3 well-known cases of a nuclear meltdown of some form. The first one happened in the United States. It's called 3 Mile Island, where essentially an operator turned off the coolant going into the reactor, and that is a bad thing. It caused it to partially melt down. There was a very small amount of nuclear material that was released, but it was minuscule. The only person who is claimed to have died during this essentially heard about this nuclear disaster, was driving in the area of the plant, freaked out, and got into a car accident. And that's the only death that is reported from 3 Mile Island whatsoever. No deaths due to radioactivity at all. Fukushima, Japan is the worst one in a first world country. You had a tsunami wave that came and hit a 1,000-year floodplain and damaged a nuclear reactor that was not properly set up for it. And that caused some issues, no doubt about that. There's been some release of radioactive material into the countryside surrounding it. But for the most part, other than a very, very small area right around the nuclear plant, there's no real radioactivity that's anything higher than the background. In fact, the entire country of Japan was, before the incident, and continues to be, a low natural radioactive area. It's much lower than the background radiation. We all are having radiation all the time. And if you go fly in an airplane, you get a higher dose of radiation because you have less of the atmosphere protecting you. Well, Japan just happens to be one of the parts of Earth that has a lower natural radioactivity. Finally, let's talk about the big one, Chernobyl. Chernobyl was an absolute disaster. It came out of Soviet-era politics. Essentially, what happened is they were trying to run a test. They didn't follow the proper process to do this test because that's how the Soviet way was. Just get it done, whatever the cost. They thought they had the ability to safely power it off in the event of emergency by pushing the scram button. It turned out, due to a fault in the design of this reactor and a fault to follow the proper procedures during an extreme test, all of these things combined together to leading the reactor to heat up very, very quickly. And as a result, it had a massive release of radioactive material. Now, there have been very, very few people who have actually died due to this. I forget the exact number, but it's like 30 people who died due to Chernobyl. 2 of them died in the explosion that just happened to be in the area right after, and the rest of them died to radiation exposure. Some of the people who were working in some insane conditions, the liquidators, to help clean all this stuff up, they've studied them people out, and none of them really have a higher rate of death due to something like cancer. You could hypothesize that maybe 100 to 200 people will eventually die to some form of cancer. The cancer that tends to be caused by something like this is thyroid cancer, which is a very treatable cancer. You have a small surgery to remove your thyroid, and you have to take a pill for the rest of your life. but it has like a 99% success rate of treatment. It's one of the most treatable forms of cancer there is. Don't get me wrong, if it happens to you, it's a miserable thing. But it really is not the disaster that many people make it out to be. In fact, wildlife is thriving in the area. And there are people who live inside of the exclusion zone that eat food that was grown inside the exclusion zone, and they seem to be quite healthy. Overall, it really did not have the massive damage that many people think it did. It definitely caused some loss of life, and it's a horrible thing, but it's not the huge issue that many people make it out to be. It's worth noting that Fukushima had a properly designed reactor, and the fuel never actually left the reactor containment unit. Now, they haven't been able to fully figure out how to dispose of it yet, but it's all been trapped inside of the facility that it's meant for. And virtually all nuclear power plants in the entire world follow these kinds of safe design principles. There's been a type of reactor that there's not a lot of in the world right now, but they're increasingly being built, called Generation 3, that these reactors actually have inherent physics such that if the coolant stops coming through for whatever reason, it will slow itself down. They took and did basically the same test as Chernobyl a couple of weeks before in a test lab in Idaho. They flipped off the coolant pump completely, which was actually kind of what happened with Chernobyl. They flipped off the electricity generation from it so that it needed to rely on the backup power, and that wasn't coming through fast enough, and that's a part of what led it to its meltdown. Not going into the whole thing, but the power spiked a little bit and then went way down without the operator touching a button other than to flip the switch to turn off the coolant to cause it to go into this state unnaturally. And any reactor that's built in the first world these days tends to follow a Generation 3 reactor. So these are fantastic. Generation 4 is the breeder reactors that I mentioned before. There are a lot of blueprints for these out there, but they have not been extensively used. Nuclear power has a few possibilities of some economic damage, but as a whole, it is fantastic. It will not release materials. One minor thing of note, it will release warm water into like the rivers or whatever that's surrounding it, as does any form of electricity. It has some potential to cause some ecological damage, but it's not a huge amount. Another little side trivia, there's roughly the same number of birds die hitting a nuclear power plant as die hitting wind turbines. So, there is, anytime you build a structure, some possibility of that kind of damage. But as a whole, nuclear power is safe and it's clean energy, and it's something we should consider more of. We'll compare it to the other forms of energy when I've finished going through all of the full life cycle of the various types of fuel that we're going to go through. But I want to cover this full life cycle in more detail. Thank you guys so much for joining me. Let me know whatever questions or comments you guys have. A big shout out to my Patreons who help to fund me learning more about this kind of stuff, and to my Discord channel who helps me to review some of the facts to try to give you guys the absolute best information that I possibly can. You guys are awesome. Thank you for subscribing, liking, sharing, and everything else that you do with my videos. Until next time, keep on tracking. Take care.